Alrighty. So we're going to look at some basic differentiation rules that are going to be so nice because we don't need to go through that whole definition of a derivative thing. Okay, so we'll only do that. It'll be a proof on a test or something like that, but we're never going to use that again unless we have to. Okay, so when do we need to use the definition of the derivative? When we're asked to. From now on, shortcuts. Okay, and don't worry, you're not losing points because you're not proving anything. These shortcuts, they're rules, they've been proven, so we're all good to go. Okay, so the first shortcut is going to be that the derivative of a constant is 0. Okay, so no matter what, get my notes out here. If you have a constant function, you're always guaranteed that the derivative is going to be 0. Now, I want you to think about, well, why would that be? Let's think about what a constant function looks like. Okay, so if this is my x and this is my y, a constant function would look something like this. Okay, let's say, who knows, y equals 1. Well, the slope of a constant function is 0. Okay, so, and it's 0 everywhere that you go. Okay, so let's look at an example. Let's say we had like f of x is 4. Okay, that's just a horizontal line that's crossing through the y-axis at 4. So its derivative, which is the slope, is 0. Okay, let's say we have something like that. Okay, so we're not used to seeing functions looking like that. Be careful with pi, because as we start working with variables, there's something about pi that our brain likes to think of it as a variable. It's not, it's a constant. Okay, so again, I'm just going to make a note because it happens all the time. And it's not because you weren't thinking about it, it's just that your brain sees that symbol and it's like, oh, this is a variable. Okay, so that's a nice little easy one to know. Okay, now if we have the derivative of a single variable, that's always going to be 1. And again, I want you to make sure that you understand why it's doing this. Okay, so let's say that this is the function f of x equals x, or you can think about it as the y equals x line. Well, that line always has a slope equal to 1, no matter what. Okay, so really you're just going to remember that if you have that function, the derivative of that function is 1. Okay, so those two should make sense of why they do that. Now, one of the ones that we're going to use most often is the power rule. And we're just going to take their word for it that this is how it's going to work. Okay, so remember that d dx, that's just another symbol for power, or excuse me, symbol for derivative. So they're saying the derivative of some variable to some power. Basically, we're talking a lot of polynomials and rationals, is equal to, you bring the n down in front, and then you subtract 1 from the n. And I'll show you an example of that. And n has to be a rational number in order for this to work. Okay, so let's just look at some examples. Let's call it A. Okay, and remember that sometimes it says y, sometimes it says f of x, I'm just going to go back and forth in between, just so that we're okay with either way. Okay, so if we want to find the derivative of that, we're going to bring the 2 down in front. And I'm going to write y prime. So I write my derivative based on what I was given. If I was given f of x, then my derivative is f prime of x. If I was given a y, my derivative is y prime. So we bring down the 2, and then notice it says to take n, whatever that variable was right up there, and subtract 1. Okay, so subtract 1 from the exponent. And it's always going to work this way. So y prime is 2x. So much better than having to use that rule for finding a derivative. Okay, so let's say we have f of x equals x to the 4th. Okay, I'm going to use my power rule. I'm going to bring down the 4. So this time I'm going to write f prime of x. And then I subtract 1 from the 4. And that's a 3. Okay, I'm going to put c over here. Let's say I have y equals the square root of x. So it doesn't necessarily look like the power rule, but we always want to rewrite that as y equals x to the 1/2. Okay, so that's a rational number. Okay, rational number just means it can't be irrational. It can't be pi, the square root of 2, something like that. Okay, so now I'm going to find the derivative. I'm going to bring the 1/2 down. Now remember what I have here. I had a half, and I have to subtract 1 from it. So I still got this 1/2 right here. 1/2 minus 1 is negative 1/2. Okay, now sometimes we just leave our answer like that. Sometimes, and you'll see because of how it's written in the back of the book, we're going to write it as 1, 2, or on the worksheet, x to the negative 1/2. If I bring it to the bottom, it becomes positive. So, and remember, the 1/2 is only on the x. It's not on that 2. Okay, so I could say that y prime. So either answer would be acceptable unless for some reason the directions said don't have any negative exponents, or I told you I want your answer in the same form as the book, or on the answer key and the answer was like that. There's advantages and disadvantages of both forms, but I just want you to be aware that they both exist. Okay, I'm going to put D over here. Okay, so let's say we had g of x. Now again, we're going to see a rule we're going to see a quotient rule and a product rule, but the quotient rule is really long, and we don't want to use that if we don't have to. So I'm just going to rewrite this. So it's still g of x. I haven't found the derivative yet, but that's the same thing. Okay, so now I'm going to find the derivative. So I'm going to write g prime of x. I'm going to bring the negative 1 down. Oops. Okay, so I'm at negative 1 and I have to subtract 1. And normally you don't necessarily have to show all of this. At first, it's helpful when you're just getting used to these to see where everything came from. But these will become kind of like when you guys first learn radicals, and now you can do radicals in your head with no problem. These ones here are going to become the same way, that you'll just be able to very easily find these. Okay? So that is our product rule. Okay, now, there's another rule that we call the general power rule. I don't know. To me, it's the same thing as the product rule, but I'm going to give it a different name since AP likes to give it another name. So we're going to call it the general power rule. And all that it's saying is it's saying, okay, well, maybe there's something in front of that variable at first, okay? All right, it'll work the same way. But they're just saying whatever number is in front of there. Well, just like before, and you're going to go a times n times x to the n minus 1. So hopefully you're kind of saying, yeah, that's pretty much the same thing. Okay, so let's look at some examples of that. Okay, so the only difference is we have the 3 in front. So y prime, I'm just going to go 2 times 3 is 6, and then there would be this 2 minus 1. And there's my derivative. And we could put this into one of our formulas, like the definition of a derivative, and you would be like, oh my gosh, that would take so many lines to get that right there. Okay, let's say we had something like this. And we're going to see a lot of stuff with this s of t. We're going to call that the position function once we start working with velocity and all of that. Well, the derivative of that function, 3 times negative 5 is negative 15. 3 minus 1 is 2. Okay. Say we have something like this. So first thing I'm going to do is I'm going to rewrite it. So notice there's no prime because I'm not finding the derivative yet. Okay, so I'm going to bring down the 1/2. So I have 1/2 times 6. And remember, we have 1/2 minus 1 will be negative 1/2. So now, half of 6, oops, and I should put the prime there because I am finding the derivative right here. Okay, so half of 6 is 3. And sometimes that form is acceptable. Sometimes we'll want it written like that. And sometimes we'll want it written like that. They all mean, oops, the same thing. Okay, I'm going to make a part 2 to this video because it's getting kind of long.